Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Math Night. I'm so excited to be here with all of you today. For those of you who are new, welcome. For those of you who are returning, welcome back. We are here every Wednesday at 7 o'clock, and I just love spending my Wednesdays with you doing these math problems. Already we have a few questions, so I'm just going to answer those questions right now. Someone asked, where is Anderson? That's a great question. I get it a lot. Anderson is no longer with us. He's been gone for about a year. He just moved on to bigger and better things. And so I am now the math specialist here at the Learning Liaisons. He was amazing. And so that's where he is. He's not with us anymore. He moved on to bigger and better things. And do we have pre-K through 3 math classes? We are working on those right now, but we do not have them up and live. However, myself and Priya, who are both math people with Learning Liaisons, offer tutoring in pre-K through 12. So we can specifically cater tutoring to that pre-K through 3 class. Santiago, also on these Math Wednesdays, I usually try to make sure that I have at least 1, if not 2, problems that are very specific to that pre-K through 3 math class. So you can go back and watch some of the other videos and stay tuned for our other Wednesdays. But until then, I apologize. We are working on that. We have a long list of courses that we're trying to get uploaded. Now, while we're waiting here, I want you to go ahead and comment below where you're from and what test you're prepping for. I love to know where my people are from, and I also like to know what test you're prepping for because it helps me guide our conversation for the evening. The problems are pretty much set. However, it helps me know what rabbit trails to take. So definitely comment and let me know where you're from and what test you're prepping for. Stephanie, you took your GK math 2 weeks after studying. Oh my goodness, I am so happy that you passed. I love success stories, so congratulations. Stephanie, Let's throw Stephanie all the congratulations in the comment box. That is amazing. Awesome. Congratulations. All right, let's go ahead and get started with our first problem. So our first problem is this one, and I'm going to go ahead and make it a little bigger for us. A gardener wants to create a unique garden for their business. She wants to have a circle that has a diameter of 8 yards, filled completely with greenery, inscribed inside a square that has flowers planted in the remaining space. All of the plants will use the same type of soil, which costs $12 per square yard. All of the flowers will cost $10 per square yard, and the greenery will cost $8 per square yard. What will the cost be for the soil and the flowers? Holy moly, that is a ton of information. To be quite frank, the first time, well, I created this problem, but as I was just reading it to you guys, I already lost track of what we're dealing with. It's important to read a problem more than once sometimes when we have a lot of information, but it's really kind of a straightforward problem. This is a problem you will likely see a similar problem on anything from like a GK math, Praxis core math, all the way to like a 6 through 12, 5 through 9 math. However, my pre-K through 3 and my K through 6 people, you have to understand how to find area and you have to understand shapes. So even though you may not get as complex of a problem as this, there are pieces and parts that you've got to know. So these are the kinds of problems I like to do because it really hits a variety of people who are in here right now. All right, let's go ahead and read it again and kind of highlight through some information that we know. A gardener wants to create a unique garden for their business. Useless information. She wants to have a circle that has a diameter of 8 yards filled completely with greenery. I'm going to stop there and draw that because as we're doing a problem like this, we got to have a visual. So she wants to have a circle with a diameter of 8 yards. A diameter, vocabulary is important. If you don't know what a diameter is, this problem is going to stump you. So geometry vocabulary is critical. A diameter is a straight line that goes through the center of the circle and touches the circle on each end. So it goes through the center and it is 8, which means this side is 4 and this side is 4 as well. We could also draw the diameter this way or this way or this way, just as long as it goes through the center of the circle and touches each side of the circle. Then what do we notice? This circle is inscribed inside. That means it's inside the square as tight as it possibly can be, a square. Okay, so let's draw our square. And this square, the circle is going to touch the ends of the square because, and goodness, this is going to be interesting to draw. There we go. There we go. I went too high. All right, we're going to try this one more time. Here. Oh, you know what? Maybe I should draw my square first. Okay, there's my square. It's not very pretty, but that's okay. So, inscribed inside of a square that has flowers planted in the remaining spaces. So, all of the blue is going to be flowers. And if I drew that properly, all of those spaces would be the same size. I'm just not an artist. I'm a mathematician instead. Then what does it tell us? Then it tells us all of the plants will use the same type of soil. So the greenery and the flowers are going to use the same type of soil, which is $12 per square yard. The flowers cost $10 per square yard, and the greenery costs $8 per square yard. And what are we actually trying to find? Because that's a lot of numbers that they've given us. The cost of the soil and flowers only. So I only want the cost of the soil and flowers. What do I not need? I do not need the cost of the greenery, but I need the cost of all of the soil. Well, it told us that everything uses the same soil, the greenery and the flowers. So if I'm trying to find the cost of the soil, I know that I'm going to have to find the area of the entire square, all of it, because that's the whole garden. And if I find the area of the whole garden, then I can find how much the soil for the whole garden is going to cost, because the cost is per square yard, which is an area measurement, because area is square measurements and perimeter is linear measurements. So the area of the square, if you've been with me before, you know that this iPad likes to do this sometimes. So we're going to just reconnect. Would you multiply? Yes, we're going to multiply to find the area of that square. Good, Santiago. While we're waiting for it to connect, hey, Hope, welcome back. GK Math, Santiago. So registering for that GK Math course is going to be perfect for you for that. Teresa working on the GK first attempt. Awesome. Welcome. And Gina working on the GK Math. But yes, you will pass it. I am confident in that. So how do we find the area of this square? We know it's a square. They told us it's a square. What is the measurement of one of the sides of the square? The measurement of one side of the square is going to be 8, because the diameter of this inscribed circle is 8, and the circle is touching the edges of the square. So because it's a square, both sides are going to be 8. So the area of the square is going to be length times width, which is 8 times 8. Pre-K through 3, K through 6, you got to know this. 8 times 8 is 64. Now that I have the area, I need to find the cost. So if the area is 64 yards squared, and it costs $12 for every square yard, yes, we are absolutely going to multiply. So we're going to take that 64 and multiply it by 12 to find the cost of the soil. Soil cost. I'm going to use my handy dandy calculator just because I want to make sure that I don't make a silly error. Some people get calculators, some people don't. You just need to know your test. 64 times 12 is $768. That's the cost of the soil only. Now I need to find the cost of the flowers, because it asked cost of the soil, check. Cost of the flowers. Here's the tricky part. The flowers cost $10 per square yard, but I have to find how many square yards I have. Well, I have these little blue spaces, and that's all flowers. I don't want this section because that is the greenery. I only want these little blue sections of flower. So what I have to do is I have to find the area of the square, which we already did, and then I have to subtract the circle out of it. So I take the whole square, and then I pull the circle out of it, and I'm left with those little pieces. Where does the 4 come from? I'm actually just about to get there. So that's a great question. So this is the area of the square. Let's find the area of the circle. The area of the circle is pi r squared, where pi is going to be a number. 3.14 is what we can round it off to. So I have pi times radius squared. What is the radius of this circle? The radius of this circle is 4. Why is it 4? Because the radius goes from the middle to the outside. We were told that the diameter was 8, which goes from one side to the other side of the circle. If the diameter is 8, then we know the radius is going to be 4. So 4 plus 4 is 8. I cut the 8 in half, and I have 4. I need that 4 for my area formula. So this equals 4 times 4 is 16 times pi, which is also 3.14. So 16 times 3.14 is 50.24 yards squared. That's the area of the circle. Now we have to take the area of the square and minus the circle. So 64 minus 50.24. 64 minus 50.24 equals 13.76. What does that number represent? We got a lot of numbers going on. That number is the area of flowers. That number is the area of flowers. Multiply that by the cost of those flowers, and we're golden. The cost is $10 per square yard. So 13.76 times 10 equals 137.6. And now if I add 137.6 plus 768, because that was the cost of the soil, this is the cost of the flowers, add those two together, 768 plus 137.6, and we get 905.60, which is B. It's a lot of information. It's a lot of steps, and it's a lot of application, and that's what you're going to see. You're not going to see a whole lot of what's the area of this circle. You're going to see application. I love that you guys are asking questions in the comment boxes. That's what's going to help you understand the problems better. So if you have questions about what I'm solving or you don't understand something, comment in the comment box. I love interacting with you because that helps me and it helps you. It helps me understand what you're doing as well. So let's go ahead and move on to the next problem. The length, width, and height of a rectangular prism box Y, respectively, are 6, 12, and 14. A similar rectangular prism box, Z, has a length, width, and height of 12, 24, and 28. The area, and that should not say parallelogram, that should say the area of rectangular prism Z is how many times the area of rectangular prism Y. Typo. Rectangular prism and rectangular prism. Okay, so let's go ahead and draw our rectangular prisms. So we've got a rectangular prism Y, and then we've got another rectangular prism Z. So this one's Y and this one's Z. Length, width, and height are 6, 12, and 14. So 6, 12, and 14, 12, 24, and 28. And we know that these are similar. They told us that they are similar. What is the difference between congruent and similar? Let's talk about that. All vocabulary that everybody needs to know. Congruent versus similar. Congruent means they are identical. A congruent shape or two congruent shapes are two shapes that are 100% identical to one another. Size, shape, the whole 9 yards. Similar means that they've been proportionally stretched or shrunk, but they are the same structure, I guess, if you will. So it's kind of like in Microsoft Word or PowerPoint when you have like a picture, and here's my picture, what's gonna happen, and you know when you click on a picture and it has those little dots that you can like drag the picture out with, what's gonna happen if I just drag this dot right here? It's gonna proportionally stretch that person, and it's not gonna look right, is it? Like that person's gonna look like this. So those are not similar. What's gonna happen if I pull on this dot? It's gonna proportionally make this person not proportional. Like this person's now gonna look like this instead. By doing both of those, it's like that person is stepping into a funhouse mirror. It doesn't work. However, if we pull on the corner, what's gonna happen? If we pull on the corner, it just makes the picture blown up or bigger, but the person or the features don't get all distorted. So now, if we know that they are similar, we know that they are proportionally alike. So let's go ahead and look at these two shapes. 6, 12, 14, 12, 24, 28. What do you notice about the patterning of those shapes? It's being multiplied by 2. 6 times 2 is 12. 12 times 2 is 24. 14 times 2 is 28. So indeed, these are similar. But then it says, and this should also say volume. Wow, I just really messed this problem up and didn't check my work. The volume of the rectangular prism, Z, is how many times the volume of rectangular prism, Y. Well, how do we figure that out? Well, some of us may actually have that memorized, but let's go ahead and figure it out. How do I find volume of a shape? Volume of a prism is the area of the base times height. Well, our base is rectangular because it's a rectangular prism. So I'm going to multiply length times width and then times height. So 6 times 12 times 14 and 12 times 24 times 28. Let's go ahead and do that in our calculators and figure out what we've got. 6 times 12 times 14 gives us 1,008. 12 times 24 times 28 gives us 8,064. If I divide this one by this one, it'll tell me how many times it is of the other one. So if I divide those two by each other, this one is 8 times bigger than this one. And you're sitting there going, but how is that even possible? We multiplied all of the sides by 2. So why wouldn't it be 2 times? That's a great question, because we multiplied the linear measurements by 2. We did not multiply the volume by 2. And so because I multiplied each of these linear measurements by 2, I have to take those 2's and multiply them together to figure out how that affects the volume as a whole. 2 times 2 times 2 is 8. So what we really did was we took those 2's and multiplied them together to figure out how many times the volume is of this shape. But because they gave us numbers, it was easy for us to quickly figure that out without knowing that. Let's go ahead and keep going to the next problem. We have a really strong geometry focus tonight because geometry has been something that people have been asking for in previous sessions. If there is something specific that you want me to focus on in future Math Wednesdays, please comment and let me know sometime before we close out tonight, because I'm more than happy to add that in. as I'm developing the problems for each week. It helps me if you're like, hey, I really want to see more problems related to linear equations or probability or whatever. So comment in the comment box and let me know what you want to see, because this is for you. All right. Which of the following formulas shows the volume of the image below solved for the height of the base? If little h is the height of the base and big H is the height of the prism. This is an interesting question. Which of the following formulas shows the volume of the image below solved for the height of the base? Santiago, I see your question and I will go back and answer it as soon as I'm done with this one, because that is an excellent question. Solved for the height of the base. We can already eliminate two of these answer choices because two of them are not even solved for height. They're solved for volume. So we can already get rid of A and B because it is solved for volume. When it says solved for, that means they want that variable to be by itself equals everything else. So because these are V equals equations, those are solved for the volume of the prism. They are not solved for the height of the base. So let's go ahead and write out the formula for the volume of this prism and then solve it for H. So we know volume equals area of the base times the height, where big B is area of the base. Now, what is our base? This is a triangular prism. Now, don't get confused and think that because it's sitting on this side that this is a rectangular prism. We look for the two identical shapes, K through 6, pre-K through 3. This is for you. What I'm about to say is for you. You got to know how to categorize shapes and GK and Praxis Core. Categorizing prisms and pyramids. We know what it is based on the shape. A prism has two identical bases with rectangles surrounding it. So because this has two identical triangles with rectangles surrounding it, we know this is a triangular prism. So these are actually the bases, even though it's not sitting on that side. So what is the area of a triangle? Area of a triangle equals 1/2 base times height of the triangle. So the height of this triangle would look something like this. So volume equals area of the base times the height of the prism, which I'm going to swap that out for a big H because they defined big H as the height of the prism, which is going to be the distance between your two bases. Now I need to solve for little h. So I'm going to divide both sides by big H. So 1/2 little b little h equals V divided by big H. How do I get little h by itself? Continue to divide. Divide both sides by little b or multiply by 1/b. So little b is going to join big H. So V over little b big H equals 1/2 little h. Now I can divide by 1/2 or I can multiply by 2/1. If I multiply by 2/1, everything crosses off. And if I multiply by 2/1, I get a 2 on the top. So I have little h equals 2V over BH, which is C. Did that make sense? All right. Santiago asked an excellent question. Let's go back. If this question asked for area instead of volume, would the answer be A? No. If it asked for perimeter instead of volume, it would be A, because we multiplied the linear measurements by 2. Area is not a linear measurement. Area is a square measurement. So because we multiplied the linear measurements by 2, we would have to multiply the length and the width by like the 2's from the length and the width to find the area. So the surface area would be 4 times, because 2 times 2 is 4. If they asked for the perimeter, it would be A. Excellent question. All right. A cake company is building a cake structure for an event. This problem reminds me of Buddy from Cake Boss, or what's the other guy? And they have like competitions on Food Network. Buddy versus, I don't know who the other guy is. If you know, let me know. But it's like Buddy versus someone, and they make these crazy cakes. That's what this reminds me of. A cake company is building a cake structure for an event. They need to create a pyramid that is then truncated at the top, shown in the image. What is the volume of the bottom truncated portion of the pyramid? Whoo! Yes, Duff! Thank you! I was hoping someone would know the answer to that. Buddy versus Duff. Yes. So, Buddy versus Duff, they're building this cake structure. And it's truncated, which just means it's cut off. So we are cutting this part off, and we're only using the bottom truncated portion. Now, I don't know about you, but I don't have a formula for the bottom truncated portion of a pyramid. So what we have to do is we have to find the volume, because we're looking for volume. We have to find the volume of the big pyramid. And then we have to subtract the volume of the small pyramid on the top. So we have to find the big volume, and then we have to subtract the small volume, and it'll give us the leftover. Well, in order to do that, we have to have the volume formula for a pyramid. Volume formula for a pyramid equals length times width times height divided by 3. Length times width times height divided by 3. Now, it's length times width because this is a square or a rectangle. So it's actually a rectangle. So because this is a rectangle, we're doing length times width and then times height. But if this was a hexagon or something else, we would have to do the area of that base. So let's find the volume of the big one first. So we're going to do big in green. So volume equals length times width, 5 times 7 times 18 divided by 3. Now, don't get confused and think that the height is this measurement. The height has to go from the top straight down into the middle of the base. It is not the slant height. Keep that in mind as you're solving these problems. Height is how tall the shape is from the bottom to the top. It is not the slanted height of the pyramid. All right, let's use our calculator. 5 times 7 times 18. 630 divided by 3 equals 210 feet cubed, because we found volume. Now we have to find the volume of the smaller pyramid and then subtract the 2. So volume of the smaller pyramid, we have to take length times width, which is 1.5 and 3, times the height, which is 4. And I didn't do a great job showing that height, but you can see that the height is that blue line right there. In the 4, I should have had an arrow pointing to it. So you knew that it was the height and not the slant height. So 1.5 times 3 times 4 divided by 3. 1.5, I'm using my calculator right now, times 3 times 4 equals 18. Divided by 3 gives us 6 feet cubed. Now I can just subtract those and I get 204 because 210 minus 6 is 204. Any questions about that? All right, I'm going to go ahead and post the link to tonight's slide deck so that those of you who are here can download the link and you can get all of these problems later tonight. So you can copy that link and it'll take you straight to this slide deck and you can use those to study with or resolve them or whatever you want to do later on. All right, let's keep going. A circle is drawn on a coordinate plane. The circle has a diameter that intersects the circle at points A and B, which are at 8, -2 and -4, -6, respectively. Which of the following represents the equation of this circle? So the equation of a circle is this, and this is definitely for my middle school and high school people. This is for my 5 through 9, 6 through 12, 7 through 12 people. Equation of a circle is this. X minus h squared plus y minus k squared equals r squared, where hk is your center and r is your radius. So what information do we need from this problem to be able to solve it? We need a center and we need a radius. Unfortunately, they gave us that this circle has a diameter that intersects at 8, -2. So let's go ahead and draw a coordinate plane. 8, -2 is going to be somewhere over here. And -4, -6 is going to be somewhere down here. And this is the diameter. And it's going to have a center somewhere in there. So how are we going to find the center and the radius? There's a lot of different pathways we can use to find it. One of the ways we can do it is by using our midpoint formula and finding the center or the midpoint of that diameter, because we know the midpoint of the diameter is going to be the center of the circle. So if I use my midpoint formula to find the center, then I can use my distance formula to find that radius. So midpoint formula says x plus x divided by 2, y plus y divided by 2. And that's going to give you your coordinate point of the midpoint of that diameter, where these are going to be my x's and my y's. So I'm going to do 8 plus -4 divided by 2. And I'm going to do -2 plus -6 divided by 2. 8 plus -4 is 4 divided by 2, which is 2. And -2 plus -6 is -8. And -8 divided by 2 is -4. So that right there is my center, which means I can get rid of A because this is not my center. And I can get rid of C because this is not my center. So now I've got a 50-50 shot between B and D. How am I going to find the radius? Well, I can use the distance formula from my center, from my center to one of the dots on my diameter, it doesn't matter which one, to find the distance or that radius. So I can use distance formula, which is the square root of x minus x squared plus y minus y squared, where this is going to be one of my points, and I'm going to pick either one of these. I'm just going to pick that one. So the square root of 2 minus negative 4 squared plus negative 4 minus negative 6 squared. Square root of 4 plus 2 is 6. 6 squared is 36. Negative 4 plus 6 is 2. 2 squared is 4. And 36 plus 4 is 40. So we have the square root of 40 is my radius. Do I need to know what that value is? No, I don't. Because the formula says r is squared. Well, the square root of 40 squared is just 40, which means B is my answer. Excellent job working through that problem. All right, any questions about that before I move on? All right, let's keep going. This is absolutely a pre-K through 3, K through 6. Everybody needs to know how to use a function table. A function table is shown below. A function table just says we have a function. What is a function? We got to know the definition of a function, not to solve this. We just should know the definition of a function. And a function is a graph or a set of points that does not have an input or an x value repeated. So here's a table. We have an input and an output where this is an x and this is a y. How do I remember that input is x? Because in the alphabet, x comes first, and in the alphabet, I comes first. What is the rule that is demonstrated in this table? So really what they're asking is, how am I getting from my input to my output? How am I getting from my input to my output? Not how am I getting from my input to my input, and not how am I getting from my output to my output. It's how am I getting from the input to the output. So what I would do here is just use my answer choices. I'm going to just use my answer choices to help me. Add 4. Is 12 plus 4 25? No. So my rule is not A. Add 2. Is 12 plus 2 25? No. So it's not B. C. Multiply by 2 and add 1. Is 12 times 2 plus 1 25? Well, 12 times 2 is 24, and 24 plus 1 is 25. However, a lot of times when they give you an input-output table, they will give you a rule that works for the first one, and they'll give you multiple rules that work for the first one. But then only one of those rules will work all the way down. So if it works in the first box, I'm not going to automatically pick that as my answer. I'm going to test it 1 or 2 more times. Is 14 times 2 plus 1 29? Well, 14 times 2 is 28 plus an extra is 29. 15 times 2 is 30 plus an extra is 31. So we've just found our rule. Divide by 2 and subtract half. Well, 12 divided by 2 is 6, and then subtract a half would be 5.5. That's definitely not going to be our answer. So pre-K through 3, you're going to see the rules written out like this. K through 6, you could see them like this. You could see them like this. And everybody else in here, you will likely see them written out like this. Same problem, just represented differently. Now, let's go ahead and do this one because I did pick different numbers, but I want you to see that these problems are the same. It's just that we're representing them in a different way. This one, we're representing the rule using words. This one, we're representing the rule using an actual function. Let's go ahead and explore this one. A function table is shown below. What is the rule that is demonstrated? So in this case, if you're not familiar with slope-intercept form, how to use slope-intercept form, I would just plug in my answer choices. So I'm going to take my input and my output and plug them into these equations and see which one works. Now, like I said, they will often have the first one work in multiple equations, but then you have to test others. So I usually like to start with like the third set. Remember, this is your X and this is your Y. So I'm literally just going to plug this X in for X and this Y in for Y and see if it's true. So 9, because I plugged the 9 in for Y, equals 3 times 2 plus 3. 3 times 2 is 6. 6 plus 3 is 9. Does it work? I got really lucky. It does work. So I'm going to go ahead and test another point in that same equation just to make sure. 12. 12 equals 3 times 3 plus 3. 9 plus 3 equals 12. We have found our answer. Now, let me show you what happens if we tested it in the wrong equation. Let's go ahead and test this green point in here. 12 equals X plus 3. I'm testing this one right here. Is 3 plus 3 12? No. 12 equals 6. That's not true. So we know this is not a rule for this function. Now, for those of you who are familiar with slope and y-intercept and you don't want to plug in points, you could use slope to figure this out. We know that the slope formula is y minus y over x minus x. So if I just pick 2 points out of these, which I'm going to pick these bottom 2 again, y minus y over x minus x. 12 minus 9 is 3. 3 minus 2 is 1. So my slope is 3. And the only equation here that has slope as 3 is this one, because remember, y equals mx plus b, where b is your y-intercept and m is your slope. And if this is going over your head, but you understood this, that's fine. Well, it's fine if you don't have to know slope on your exam. So y-intercept is b, slope is m. If you solve for your slope, and then you look at your equations, A is the only one with a slope of 3. Will there be enough time to solve questions on the test? That's an excellent question. Yes, there's always enough time, according to the state, to solve these questions. Now, on the GK, you're going to get anywhere between 40 and 45 questions, I believe. And you get something like 120 minutes. Let's see, 40. Yeah, you get like 100 or 120 minutes. I can't remember it off the top of my head, which is about 2.5 minutes per question. Now, I love that you asked that question because a lot of times I'm sitting here doing only about 6 to 10 problems in an hour because I'm expanding so much on these problems to try to hit as many people as possible. So I just went through this whole process and I tested this one, and that was not necessary. This problem could have been done a long time ago, but I'm trying to show you all the different things that this problem could encompass so that I'm hitting on a lot of different topics. That said, yes, there's enough time according to the state, but a lot of people don't finish. You have to use your time wisely. So if you have any other questions about that, let me know. All right, let's move on. Which of the following demonstrates the use of the associative property of addition. This is an interesting problem because if you don't know what the associative property of addition is, this is a shot in the dark. Don't waste your time on it. If you got this problem on your test and you had no idea what that was, then I would guess and move on. I would not waste any time on this if you truly, truly, truly did not know the definition of this. Guess and move on. Don't waste any time on this problem. Now, right now, we're going to waste time on this problem because you need to know what the associative property is. So let's define all of the different properties. We have associative. We have distributive. We have commutative. We have identity and zero. Associative property says that if I have addends or things that are being multiplied, so like 3 plus 4 plus 9, and I was going to do 3 plus 4 first, I could do 4 plus 9 first instead. I could do 3 plus 4 plus 9. Associative property is where we take parentheses and we move them, but everything stays in the same order. So in this case, letter B is going to be our associative property. Commutative property, I'm going to come back to distributive property, I promise. Commutative property says that if I have 3 plus 4 plus 9, I could do 9 plus 3 plus 4 instead. I can move those items around and it's still going to give me the same answer. So letter C is actually going to be commutative property. And here we go, I disconnected again. Distributive property is exactly what it sounds like. You're distributing something into the rest of the problem. So if you think about distributive property, you're usually taking an item that's being multiplied into a set of parentheses and distributing it all the way through. So if I had 3 times 4 plus 9, I could do 3 times 4 and then 3 times 9, which is going to be letter A. Identity property says that if I add 0 to an item, it's still going to be itself. So if I have 3 plus 0, I'm still going to get 3. Now, here's what I want you to keep in mind. We could have commutative property of addition, associative property of addition, identity property of addition. We can also have associative property of multiplication, commutative property of multiplication, and identity property of multiplication. Associative and commutative property of multiplication look the same. But identity property of multiplication is not going to be the same. 3 times 0 does not give me 3. So the identity property of multiplication is going to be 3 times 1 gives me 3. Just with identity, all you want is you want to get the same answer. Like, that's the identity of that number. Like, I'm Amy Sink. I'm not changing. This is the number 3. We don't want it to change. So in multiplication, we multiply by 1. And with addition, we add 0. So if you don't know your property names, this would be a very difficult problem for you to solve. However, if you know your property names, this problem takes 20 seconds and you've just bought yourself some time on another problem. So know your property names. Same with geometry. Know those geometry terms, because if you know them, some of those problems are going to go lickety-split, and then you can save time on some of the other problems. All right, we didn't quite get to the last problem. We will do that one next week before we solve the set of problems that we have for next week. Before you leave, let me know what you want me to focus on next week or the week after. We will still continue these Wednesday sessions for quite a while, indefinitely. So I will be here with you. So let me know what you want to see me solve in the future. I'm going to turn it back over to Dr. A, but I'll still be hanging out, watching for those comments. I can't wait to see you next Wednesday. Have a great day. Congratulations again, Stephanie. And for those of you who are studying, keep on keeping on because you are doing a great job. These tests are not easy, so keep working hard. I'm going to turn it back over to Dr. A, and I will see you guys next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.